Hello everyone, welcome to Qonfest2021. My name is Benoît Barbeau. I'm Associate Professor in University Paris-Est Créteil, and I am General Chair of Qonfest for this year. I'm here with my colleagues, Daniele, one of the PC Chair of Concur, and Cataline Dima, which is one of the PC Chair of Format and is the Vice Dean of my faculty. Like last year, due to the COVID-19 pandemics, we are not able to meet in person and we'll instead meet online. Despite of not being able to host you here in Paris, Créteil, I'm very happy for this conference because we have a very interesting program. The PC of each conference received good contribution and were able to build an exciting program. Many good orators have accepted to speak for our keynote speech. And last but not least, we receive a huge number of registration. We have more than 470 people registered today. And we have participants from 38 countries from all over the world, which I found quite impressive. Similar to what was done in Qonfest 2020 in Vienna, we'll use Zoom and the recorded video for the talk. You can access the program on the web page of the website. So you go to qonfest2021.lacl.fr/venue. And you have the full program. You need to use the password I sent you Friday evening at the end of the registration to unlock the full program. And on the full program, you have link to the video teaser for each session, link to the Zoom session, and link to the proceeding for each paper. So you can use this web page as the main starting point to reach any part of the conference. You can also watch the teaser directly from the YouTube channel, and we will record each session and put them on the YouTube channel. An important part of jointly organizing several conferences together is to be able to have interaction between community. So we'll try to keep a very tight schedule between the different conferences and the different tracks. So you will be able to switch and cherry pick which session you want to follow. And another important part of conferences is the socializing part. And as we are not physically in Paris, we really miss the social dinner that we were not able to organize, but I want you to have still some socializing, and we propose you a virtual venue on Gathertone, where you will be able to simply discuss with other Qonfest attendees. So I greatly prompt you to connect to this platform, especially during breaks, to engage discussion with the other attendees. When you are presenting a paper, please stay in the virtual room of your presentation during the following break. So if there are additional questions that there was not enough time to answer during the session, people can still go to find you and start a discussion on your work. I would like to thank all of our sponsors, because thanks to them this year the registration was free for the attendee. Our sponsors were my university, the Université Paris-Est Créteil, INRIA, Nomadics Lab, ERSIN, and LNCS. I want also to thank all the people who helped to prepare the program of this conference, the PC chairs, PC member, reviewer, who helped put together this program. The conference was possible thanks to the work of all the administrative and technical staff, the work of the webmaster and designer, and finally, all the PhD students who will serve as technical chair for each session. But I greatly thank them. So now I will let Cataline Dima speak as Vice Dean of the Science Faculty, which she is hosting us today and hosting this conference, and he will tell a few words about this university. I wish you to enjoy Qonfest 2021. Cataline.
Thank you.
I'll keep you.
Okay, so Hello, everyone, and welcome to the joint international meeting of Qonfest 2021. Qonfest 2021 is hosted virtually by the Université Paris-Crete, or UPEC for short, which unfortunately, as Bernard has said, you cannot visit due to the COVID pandemic situation. Our university has several campuses in the southeast part of Paris, with the main campus in the city of Crete, which is here, and which is the administrative center of the French department of Val-de-Marne, which is number 94. And some other campuses are in the other department of Seine-et-Marne, which is 77. For those who know, Paris number is 75. Crete is one of the new cities built in the 60s, and exhibits some examples of urban architecture of that period. You may have asked what are these last two buildings in the skyline of Qonfest here. Maybe you have identified the other buildings. So these last two buildings, one of them you can also find on the image of the campus of the Crete University, is the Crete Law Court, which has the shape of a law scale. And the second building is part of the of an urban architecture quarter, which is the Le Chou et les Épis, which basically means the cauliflower and the corn ears, which has been labeled as 20th century architecture heritage. Okay, so Université Paris-Crete has been created in 1970, when the big Université de Paris was split into 13 universities and several other schools. UPEC is a multidisciplinary university consisting of 12 faculties or institutes covering a lot of science and technology and arts and humanities, medicine, management, economy, and so on. And one of these faculties, composing faculty, is the Faculty of Science and Technology, which is the faculty that hosts Qonfest this year. So the research and training strategy in this multidisciplinary university has been organized around 5 directions for strategic development, and I will only cite one of them, which is this digital technology, science and practice, which concentrates on the problem of modeling, representation, the use and protection of digital, complex and big data. And the Qonfest events fits in this research and training strategic line. So the Faculty of Science and Technology of the Université Paris-Crete hosts also a multidisciplinary science and technology curriculum, and we have 4,000 students which enroll in the bachelor, master, and PhD programs, 200 professors and researchers, 80 administrative and technical staff, and 9 research labs covering all the domains from maths to biology and earth sciences. Among all these labs, we will cite the Laboratoire d'Algorithmique, Complexité et Logique, which is the other co-host of Qonfest, and to which I also belong. I will also take the opportunity to speak of one of the nice projects that we have at the Université Paris-Crete and the Faculty of Sciences, which is the Space Campus, which hosts a series of student projects for designing and developing some space-related devices and technologies, like nanosatellites or like rovers. The nanosatellites are supposed to be launched. One of them is this nanosatellite, this 3-cube nanosatellite, which is supposed to be launched in 2022. and the other is a copy of the Rosalind Franklin rover, which is supposed to be which it will just be a copy that the students are developing here, a copy of the Rosalind Franklin rover, which is supposed to land on Mars in 2022. Okay, so thank you for your for coming and assisting at this nice event on behalf of the Dean of the Faculty of Sciences, Jacques Moscovici, and its board, and also on behalf of the director of the Laboratoire d'Algorithmique Complexité and Logique, Julien Servel, and its deputy director, Pierre Balarcher. We welcome you for this edition of Qonfest and hope you will enjoy the talks and virtual social events. Thank you.
Thank you. Okay. So now I will let Parash speak to present the next the first keynote speaker. But I need just to invite him. So where is he?
I'm here. Do you hear me?
Yes, but I'm still waiting for the keynote speaker.
Daniele is there.
Yes, so now he should be able to speak. Please, Daniele.
I'm here, thank you.
Okay. So please, Parash.
So thank you very much and welcome everybody to this first session, and welcome especially to Daniele. I am happy to chair this session, and I think Daniele is an excellent example of a few researchers that combine academically interesting research with relevant challenges and practical applications. And I think as a research community, we should be grateful for having such researchers, because on the one hand, such work or such researchers, they expose us as a research community to the outside world and perhaps show our relevance and our ideas, which is very nice. On the other hand, we get feedback, so they will help certainly to extract new challenges that are vital for the progress of research in academia. So this is a very interesting aspect of Daniele's work. And concretely, from what I have seen, he has done a lot of work in academia about the use of temporal reasoning, for instance, for things like solving multi-goal problems with dynamics and time windows. So this is just a concrete example of some research that he has done. But now he seems to be working in JP Morgan, and JP Morgan is, I would say, it's the global leader in financial services, offering solutions to the world's most important corporations, governments, and institutions in more than 100 countries. So an amazing combination, being an associate professor in King's College and then intersect that with work at such an institution. So I'm very interested, I'm very curious about your talk. And from what I understood, you are trying to show us how to use temporal reasoning, and now in a totally new application area, namely in the challenges that arise in the financial world. So thank you very much, and the stage is yours, please.
Thank you very much, Parush, for the nice introduction, and hello everyone. Thanks for the organizer for inviting me. It's a real pleasure to be here with you today. Let me, it looks like I can't share the screen, so I think you need to allow me to do it, please.
No, you can.
Okay, now I can, thank you. So I trust you can see my screen. So as Parush mentioned, I spent 15 years in academia, 10 of which in King's College London, and 1.5 years ago I moved into JP Morgan. And when preparing this talk, I thought what can be more useful to this community. And I thought that I'd like to give you a sense of what it means to do research in AI and temporal reasoning in the financial industry. So I will give you an overview, first of all, of what a financial institution looks like, and then a survey, if you want, of some of the projects we are working on, and also the challenges we face, because we are still very open to collaboration and we are research, so we face challenges. I will not have time to go into too many details for each project, but I like to say upfront, please feel free to reach out anytime if you have feedback, comments, or you want to collaborate on some of the projects I'll be talking about. So first of all, why I decided to move into JP Morgan after 15 years in academia, which by the way, I love. So I really loved academia. However, this was a unique opportunity to face big challenges. Now, I want to show you this slide that gives you some numbers about JP Morgan. And what I guess you can see here is that the main challenge of working in such a large institution is the scale. Because everything is really kind of gigantic in terms of, for example, employees, so 250,000 employees across the globe, but also from a more financial point of view, we have several, millions of households and small businesses and 5,000 branches across the world. And out of the 250,000 employees, 50,000 are technologies, which means there is a lot of technology and AI going on in JP Morgan. However, we are AI research, which is a relevant, new, and very recent group. So this is the leadership. So 3 years ago, JP Morgan hired Professor Veloso for CMU to establish this group that will do research on AI. And then with Tucker Budge, Samina Shah, and myself, we direct and help Manuela in leading the projects. And what I want to highlight here is that, of course, we do machine learning, reinforcement learning, deep learning, but for us, AI is much, much broader than that. And myself, personally, I'm not a machine learning person. My background was in planning and optimization and formal methods. And we do a lot of this in academia. So if there is one message I want to really strongly convey to the audience in this conference is that the topics you are researching on are really, really valuable and important for industry. Even if the AI community seems dominated by machine learning, deep learning, that's fine. But really, all the topics that are covered in this conference are very, very relevant to the industry, including the financial sector. Now, this is a slide summarizing what we call the aspirational goals. The reason why I'm sharing the broad kind of portfolio of projects we work on is because, as I'll mention at the end of the talk, we at JP Morgan seek always for collaboration with academia, also through grants and projects that we fund. So the idea is really to trigger potential new collaboration, even with people listening to the talk today. So we have 7 aspirational goals. 3 of them are foundational topics, 3 are with stakeholders, and 1 crossing-cutting theme. So in terms of foundational topics, we have number 1, AI to eradicate financial crime. Now, as you can see in these all these aspirational goals, we tend to use very big words. So we don't want to reduce financial crime. We want to eradicate financial crime. The reason why we target big goals is that the goal of our group as AI research is really to target big problems that might take a few years to solve rather than a few weeks. So we target strategic long-term goals. So one is AI to eradicate financial crime. I'll mention 1 project on that. The second one is AI to liberate data safely, and I will talk about the efforts we are doing around synthetic data. Third, AI to predict and affect economic systems. As you can imagine, there is a lot going on in terms of simulating electronic markets, for example, and predicting the behavior of markets. In terms of engagement with stakeholders, we face clients, employees, and regulators. In terms of clients, we want to what we call perfect client experience. And by that, we mean to allow the clients to have a very nice and smooth experience when dealing with financial services. For employees, we want to empower employees, and this is key because clearly for people working in AI in industry, the usual question is, will AI take over jobs for humans? The answer is definitely not. What AI will do is to empower employees, try to take on more repetitive tasks and allow employees to focus on what really needs human knowledge and human skills and expertise. And finally, we have AI to agentize policy compliance, which is where formal methods really play a key role. And I will spend some time on a project on that aspirational goal. Finally, this cross-cutting theme is establishing ethical and socially good AI. And the last part of the talk, I will describe the efforts we are doing around explainable AI, which is a hot topic at the moment, but in the financial industry is really critical. So this is more kind of overview of the type of interest we have. Let me stress once more that when we say AI here, we really mean something much, much broader than just machine learning, including a lot of formal methods and logic-based approach that we use. Okay, so I want to start with what we are doing around fraud detection. You will see across the slides people in the team who are contributing to the efforts around different projects. So for me, joining JP Morgan was really a big learning experience. I'm learning a lot, and I still have many things to learn. The first thing I learned is the impact of fraud still today. This is a very recent quote from a report on fraud from UK Finance. So these numbers relates to UK only. I want to read these with you. So unauthorized financial fraud losses across payment cards, remote banking, and checks total almost 800 million in 2020 of pounds. Moreover, banks and card companies prevented 1.6 billion in unauthorized fraud in 2020. These represent incidents that were detected and prevented by firms and is equivalent to 6.70 pounds in every 10 pounds of attempted fraud being stopped. As you see, that to me is quite surprising, means that there is a lot going on around frauds. Therefore, fraud detection is still a critical issue in the financial world. Typically, what is used to try to prevent frauds, and here we focus, for example, on fraudulent transactions, whether it's for money laundering, for example, or frauds. So the idea there is to use rule-based systems and or ML classifiers that use mostly historical data for being able to identify automatically transactions that are supposed to be fraudulent. There is also a public data set for those of you who are interested in trying to experiment with this type of data. So it's the IEEE fraud detection data set. However, one of the main issues is that false positives are a problem, meaning that a bank, they don't want to stop a transaction which is actually a valid transaction. So all the items that are identified as false positives are inspected by humans manually to check that there are no false positives. And this is done through rule-based or classifiers. So the setting here is that we want to identify fraudulent transactions, but false positives are expensive. So we want to detect the false positives. Also, we are in a setting where the vast majority of transactions are actually valid, are not fraudulent. So as you can see, the example here is pretty static. So pretty standard, we have data that go to classifiers, and all the transactions that are considered valid, they are fine. Those who are considered fraudulent, they go into a priority queue that is then expected by humans, say at the end of the day. Clearly, the issue, one of the main issues, is that there are far more transactions that are identified as frauds that can be inspected manually, given the resources. So we, as a research, were asked with the challenge, can you help us in identify a better way to understand which transaction we should inspect first. Okay, that was the problem. And so this became the AI challenge for us. How can we use AI for optimal resource allocation? Clearly, we were driven by the business need around fraud inspection, but what we come up with can be generalized to other domains and other problems. And this is how we work. So we are driven by a business need. However, the state of the art is not enough to solve that problem. That's why we need to do research. So what we did was to basically change the question from show me every payment that you think is fraudulent by the classifier to show me the most valuable payments that you think are fraudulent and that I will have the capacity to inspect. In this way, we try to optimize the behavior of the human who need to inspect the fraudulent transactions. Now, what we did was to come up with a problem statement, which again generalize, so it's driven by fraud detection, but can be applied to a variety of domains. We assume tasks arriving according to a non-homogeneous Poisson process. Here by task, we model the transactions to be inspected as tasks arriving or as job arriving. And the decision to be made is whether to accept the job or the task or not. We assume to be able to assign a value, which in our experiments is taken from an unknown distribution. And the idea is that online, immediately, you must decide whether that job, that task, needs to be accepted or not. We work with a finite capacity, so meaning that we have a capacity to accept a maximum number of tasks in total, and we have a finite but continuous time window that we work with. And so the idea we come up with, again, the idea is to come up to frame the problem as a stochastic sequential assignment problem. Now, the contribution here is an algorithm. By the way, for the details, you can go to the paper that will be presented with JK this week. I guess one thing I forgot to mention as AI research is that while we try to solve business problems, given that we have to do research for that, we do publish papers. So we are really engaged with the academic community. We publish papers and we join conferences and organize conferences also, as I'll say at the very end. In the paper, you can find the details of the algorithm as well as the proof of the convergence to optimal solution. What I wanted to show you now is what the solution looks like. So we come up with this idea of critical curves that gives the humans employees who are in charge of inspecting a criteria for which job to accept or not. So what you see in the left plot here is the distribution. These are synthetic data in this example for the value distribution of the arriving tasks. And on the right-hand side, you see the critical curves. And the idea is that each employee starts from the bottom curve. And each time point, you see the gray vertical lines. The gray vertical lines are the arriving jobs with the expected reward on the y-axis. On the x-axis, you have time. What each employee will do is that they will accept the job only if the reward is above the critical curve that they are considering. Once they accept the job, then they move into the upper critical curve and so forth and so on. This gives a new set of criteria to optimize which jobs to accept and which, in this case, transaction to inspect. Clearly, we had to handle a couple of challenges, and we leverage existing work here to understand how to deal with the fact that values and arrival intensity are known. However, the second issue is that for the decision maker, the value distribution and arrival intensity are unknown. They don't know. So we could estimate given the use of data. Clearly, being in a large institution like JP Morgan gives the opportunity to leverage a lot the data. Okay, although even there it's a challenge, as I mentioned in the second example of projects in this talk. Again, you can find the details in the paper. What I want to show is what we are now dealing with as a next step. So far, we assume to have the capacity to accept a maximum number of tasks with the goal of maximizing the total expected reward from the tasks that we were able to accept. However, the assumptions we were making from a temporal point of view, so I guess that's very relevant to this audience, is that we were assuming basically no duration of tasks. So in infinitesimally small amount of time needed for completing the tasks. However, clearly this assumption is not realistic. So the way we do is that we start simple and then we start adding complexity and realisms to the problem we deal with. So the next step was, okay, can we instead include duration of tasks in the assumptions we make, again, taken from a distribution, and how do we handle that now that it's no longer, infinitely small amount of time, but there is a duration. And what we did was to move from the small number of critical curves into a much dense set of critical curves, because now the state space is much bigger, given that we have a varying duration for tasks. Again, this is now being used in actual fraud detection problems, and particularly how to identify which transaction to expect. But as you see, the approach is general enough to be used in other domains. And this is the sense of how concrete business problems drives our research towards more general solutions. What are the challenges? As I mentioned at the beginning, I will always mention challenges because we face many challenges. First of all, there is always the scalability issues. So how to handle with the state explosion problem. Also, we are using a discretized version of the problem, how to handle continuous time setting instead. So these are two current bottlenecks that also involves temporal reasoning. Okay, let's move forward. Again, the goal of this talk is really to give you a flavor of the type of things we do. The second thing I want to talk about is synthetic data. Now, as I mentioned, being in JP Morgan gives us the opportunity to leverage a lot of data, okay? But nevertheless, real data are not enough, although they are clearly extremely valuable, but they are not enough for a number of reasons that I mentioned here in this slide. First of all, while there are data for many domains, there are domains for which you don't have real data or you cannot access them. For example, even for regulatory reasons, for privacy reasons. Moreover, in real data, you might have missing and incomplete values. And also, it can be the case that you don't find what are rare events that are important instead in many applications, particularly if you want to manage risks. You are actually more interested in the rare events than in the most standard or typical ones. Also, the real data may not allow what-if questions, which again are very important in the industry. So you want give people the opportunity to explore what-if scenarios, to see different options, for example. So the solution to these issues with real data is synthetic data. The idea is to come up with a generative process that might leverage real data, but give you synthetic data that are as similar as possible to the real data. Now, this is something we made publicly available. So if you go to the website in this slide, well, first of all, you can find more info about our group at JP Morgan, AI Research. But in the initiative section, you find the synthetic data page where we released these 4 sets of synthetic data relevant to market execution, payments data for fraud detection that I just mentioned, customer journey, so what the customers of the bank do in their journey when using financial services, and anti-money laundering data, which is also critically important for a bank, as you can imagine. These are the standard methods for generating synthetic data. The first is that you just take the real data and you anonymize them. The second method is that you can get a model that you learn, and then you sample for that model. The third one, which I want to focus on, perhaps because it's perhaps less common, is the one based on multi-agent simulation and planning. I'll say a bit more in the next slide, but this is the general approach. So you start with real data you want to generate synthetic data for, and you identify metrics to assess the quality of the real data. And then meanwhile, you generate the synthetic data, but critically, it's very important to be able to use the metric to assess whether the synthetic data you generated are similar and therefore meaningful with respect to the real data. So the metrics comparator component in this process is really important, also to revise and improve the way you are generating your synthetic data. I want to focus on planning-based approach. Again, first of all, because it's very, I would say, less standard, relatively new. Second, because, you know, it's also my background, although the credit for this work go to Daniele Borrau, who also joined JP Morgan, who is also a professor on planning. Now, planning is the problem of having a model of the world, so what action you can take, and then to have a start state, a goal you want to achieve, and come up with a set of actions that will bring you from the initial state to the goal state. That can be used for synthetic data generation. And the example is in the context of anti-money laundering or money laundering. So the goal is the following. What you can do is that you assume the goal of a malicious agent. So you say the goal is money laundering. And what you can do is you can describe the set of actions that malicious agents might do for money laundering, and you come up with a plan where the goal is, remember, money laundering. So the idea is that this plan will show you, will generate a sequence of actions which are not, illicit actions that are used to, for example, spread the money on different accounts and then transfer money across accounts. And this is a trace of a bad behavior. Set of actions that malicious agents can do to do money laundering. Similarly, you can instead model a legitimate operations, so for a good agent. And what you do is that a number of activities, including opening account and transferring money, that however relates to good behavior, legitimate operations. And in this case, you come up with many traces that again are plans in the planning notation that actually correspond to the actions that either a bad agent or a good agent might do in the context of, for example, money laundering. And this is an example of what you get. Again, sequence of actions for an agent acting with financial services that can be modeling either a good behavior or bad behavior. The goal, I think the benefit of using goal-based approach or planning approach is that you can generate really tons of examples, basically at no cost, once you have the model of the actions that, again, a bad actor and a good actor can have. It's important to highlight that your synthetic data set must contain good traces as well as bad traces. Similarly, I want to mention the Abides simulator. So we have been working our team, mainly driven by Tucker Bolch, this effort around multi-agent simulation of electronic markets. And now there is this simulator called Abides, which is open source, you can find in GitHub, which is widely used now in the context, again, of market simulation. And the good point, as you know, about agent-based simulation is that you can add arbitrary number of agents. And so you are able to simulate even, very complex behaviors. As part of this simulation, Abides has also been used for synthetic data generation in the context of market. Again, I refer you to the GitHub website where you can also find, the code for running the simulator, but also a number of material for learn how to use the simulator and where it can be used. And again, that's an example of synthetic data for markets. So on the table, first table, you see a real NASDAQ data. On the below table, you see the synthetic data generated, which are similar to the real data that you will get. And again, this has been generated using the agent-based simulation approach. Okay, that was about synthetic data. Again, please visit the website for actually getting access to the 4 public data sets we released. Challenges, as usual. Clearly, I mentioned the metrics we use for assessing real data versus synthetic data. However, the problem of evaluating the realism of synthetic data is still an open challenge. So that's the first one. Second one, how to scale. We always need to scale more and more, and it will be always a growing problem. The more we go, the more the bigger the scale will be. So how to scale. Third, how to generate data in an interpretable way, but also while preserving privacy. There are clearly domains where data are very sensitive, so privacy-preserving approaches for synthetic data is a big open area for research. Okay, that was about synthetic data. Let's move on. I want to talk about the efforts we are doing for AI to agentize policy compliance. Now, not just JP Morgan, but this applies to any large institution in finance and non-finance. There are plenty of legal sources for which institution must be compliant to, okay, in terms of processes, decisions, standards, access to data, privacy, whatever. Usually what you do is that you have legal sources, and then humans go through these legal sources and extract from the legal sources a set of legal obligations that tells you practically what can be done, what must be done, what cannot be done, and so forth and so on. And then you have large teams, compliance teams, who are responsible for checking that everything that happens in a firm is compliant to this legal obligation. And it's a very heavily manual process that involves a lot of documents, a lot of text, and many people reading the text. Plus, there are changes in the regulations, as you can imagine. So new rules or changes in the rules, and this requires a constant monitoring by humans of what changes are happening and how the changes affect the current processes in the firm. So this is how things are now. Again, that's a general problem in large institutions, particularly in finance, given that finance institutions are highly regulated. And this is where we aim to go. Again, disclaimer up front, this will take a while. We are doing intermediate step, but it's a long term that might take years, and we are not afraid to handle these long-term goals. So we have 2 components, bottom left, organization and structuring. So a key problem when dealing with a huge amount of texts is to help the people who have to deal with these texts to make sense, to organize the text, and to, for example, easily or quickly identify what they are looking for. In this sense, what we did, and you see pictures here, that basically what we did was to come up with the new unsupervised learning approaches for being able to cluster and automatically organize the legal obligations. So in this picture, the main point is that colors correspond to topics of relevance for legal regulations. And this helps humans to make a sense, to organize better this huge amount of text, but also to identify more quickly what they need to find. Bottom right, how to transform the text, the original text, into human readable form that also provide insights in an automatic way. For example, can we automatically flag or provide alerts for changing in regulations that require attention because they might affect some of the processes in the firm? Second example, explicitly flag requirements for compliance. Again, based on regulation, to flag automatically that some processes needs to be checked against compliance. risk analysis, and the last point is one of the most important ones, because clearly from the very title of this aspirational goal, AI to agentize policy compliance, clearly there are many things that AI cannot do in this space. There are things that AI can do, but many things, I would say perhaps the majority of things will still require human judgment, definitely. However, what AI can do, and this is something we always try to pursue, the AI can identify what the AI is not able to deal with and say, okay, for this, we definitely need humans. I cannot do that as an AI, while I can focus on this that I think I can be able to solve. The third point, which I'll give you a bit details in a minute, is really how to move from a set of text documents into an AI readable representation that an AI framework can use to observe, monitor, and reason with legal obligations. And again, this is a big problem. It's a really vast problem. We did some preliminary steps, which I want to share with you, because I guess it's very relevant to at least part of the audience in this call. So let's start from a concrete example. This is a public regulation, shares buyback. Basically, it's part of the regulations that govern how companies can purchase their own stocks. So you see an extract of this regulation in English, so plain text. We focus on the last part, letter D, saying the issuer cannot purchase over 25% of the average daily trading volume. Now, typically, humans read these regulations and then check the behavior of the company, okay, what they are purchasing and how much. What we try to do is, okay, let's try to move from natural language, the English you see in the top left, into a logic-based representation. And we do that through steps. So we start from a natural language, again, the last section I mentioned. The first step is to automatically translate that natural language into the controlled language, which is basically, in this case, a subset of the English with categories that allow you to categorize components of the sentence into items, like the ones you see in the slide. From that, then there is a translator of this into contract logic. Contract logic is an extension of logic that allows you to specify, for example, what you can do, what you must do, and is specifically tailored for contracts. And the idea is to translate control language into this contract logic. Once we have this logic-based representation, the next step is to come up with a final state machine that can reason with this logic-based representation. What you see here is a finite state machine that can basically check whether these constraints, if you want, in control logic are valid or not, are respected or not. And that's one example. You will find similar for many others, example in electronic markets. Once we have that, you can code, and we focus, what we did is, as a first step, is to focus on electronic markets, for which we have the simulator I mentioned before, the Abide simulator, which means we are able to take this finite state machine and code it within the simulator to make this finite state machine part of the actual simulator of electronic market maker. Basically, what we are doing is to enrich the electronic market simulator with this code, which is like a referee checking that this particular rule is satisfied or not. Once you have that in place, what you can do is to actually run abides as we did before, but now with the referee who is checking whether a number of rules are satisfied, including the ones I mentioned. So what you see here in bottom left is the simulator going through the simulation, so some transaction, and checking that this particular rule is satisfied. So it means that the behavior is compliant to all the clauses of this rule. Again, this is an initial step, but it's very promising in terms of the potential of this approach. It's a long way to go. And part of this work is, again, for the AI to identify what are the rules that will need human judgment. Okay, so in that case, the AI will say, no way I can solve that. We need to go for humans. While for other cases, I might be able. So let's go forward and make this automation happen. Again, this involves logic, NLP, formal methods, finite state machines, up to the coding within the electronic market simulator. Fine. One more line of work is AI for hybrid working. So the context here is the following. Well, at least the inspiration for working on this was that now that we are more or less returning to the office after the pandemic, many companies, many institutions are returning to the office, not at full capacity yet, but people rotate between working from home and working in the office. So the problem was, can we use AI to help the return to the office of 250,000 employees that we have in JP Morgan? So we come up with the idea of using planning and scheduling, which basically is a constraint programming approach. So for those of you who might not be familiar with this approach, the input is the resource to be allocated, and then a set of hard constraints that you must satisfy and soft constraints or preferences that it will be better to satisfy, but it's not compulsory if not possible. Meta constraints, I'll go back to this in a minute, and then the time window you want to plan for. And then the question becomes, is there an assignment that satisfies all the constraints? If yes, then you give the assignment as the output. If not, you can either tell me how to relax the constraints, particularly the hard constraints, so that the assignment exists, or you can tell me which additional resources needs to be satisfied for given all the constraints that you have. Now, in the context of rotating people when returning to the office, this is how we instantiated the general framework of constraint programming. So the resources are clearly the people in your team and the desks that you have available. Hard constraints can be the minimum number of days in the office. Soft constraints, you mean when you prefer to go into the office and when you prefer to work from home. The time window is, for example, for the next month. And something we also do was to say, okay, how can we make sure that people working on the same projects go to the office together so that they can work physically together in a meeting room? Again, if the assignment exists, you show the schedule for people when they need to be in the office. And if the solution does not exist, either you say, okay, you need to reduce the minimum number of days people need to be in the office, or you can say you need far more desks for your team. Now, a couple of things I want to highlight is the following, is that I've been working in academia with constraint programming for a long time, and I always found it fascinating. What I find new, to some extent, now that I'm in industry, is that you are faced with constraints and preferences that you wouldn't find before. Again, one example in this case was, okay, we want to collect when people prefer to work from home. However, most people might say, I want to work from home on Fridays or on Mondays. And then the problem becomes you cannot send all the same people on the office on Fridays. So there is a fairness kind of reasoning needed. So how to make sure now that your schedule or that your constraint programming model takes the fairness constraint into account. That's the one first, interesting issue we faced, we found and we had to face. The second issue is that clearly you want to show that the schedule that AI created is fair across all the employees in the team. However, at the same time, you don't want to reveal the preferences of employees, because there might be, I don't know, medical reasons, family reasons why some people have some preferences. So the challenge becomes how to explain the fairness of the proposed schedule without revealing the preferences of each employee. And again, that's an interesting research question. We are working on it. We haven't solved it fully. We have some preliminary steps, but it's kind of flavor of what it means for us to solve a business problem, like returning to the office of several thousands of people, while encountering research questions that need research to be solved. Following this work on returning to the office, we then we scaled up, if you want, and we said, okay, can we use AI to more in general optimize space or real estate usage. And the idea is that, yes, you can, and you can basically take the information about all employees working in a given building, the floor plans, and automatically schedule how people should be moved in the building in order to reduce the state space needed. I'll move a bit forward, given that I'm conscious of time. I want to spend a bit of time into Explainable AI. I want to highlight one thing. Explainable AI is a hot topic, has been a hot topic for a while. What I want to highlight here is that the temporal reasoning is crucial when it comes to Explainable AI. The second thing is that when working in a business, explainability becomes much more concrete because you have the real questions from real stakeholders. And I'll try to say you something about what our experience so far. So first of all, in last October, given how critical is Explainable AI in the finance, particularly JP Morgan created this Center of Excellence on AI, on Explainable AI, which I have the pleasure and the honor to lead. And the idea is that we tackle Explainable AI from various angles. One is with respect to our customers, then the regulators, because financial industry is highly regulated, and then practitioners, we mean internal users of AI in JP Morgan, and clearly XAI is critical from risk managers. So we are working from many angles. On the works I'm going to present in the next 5 minutes or so, I want to acknowledge the help from these people, and also highlight that, for example, we have Jason Long with a PhD in maths, or Cecilia with a PhD in philosophy, Josh in computer science. So we have a variety of skills working together towards explanations. First of all, the first contribution was to come up with this taxonomy of types of explanation in finance. And for those of you familiar with XAI, you will all agree, I guess, that explanation strongly depends on the audience, on the target of explanations. And this becomes particularly important in finance. So the first type of explanations is explanation as actionable recourse, whereby the target is the consumer of AI models, for example, our clients. As you might know, when people apply for a loan and they get rejected, they ask, why did you reject my loan application? And given that very often AI is used to make decisions, you need explanation from an AI point of view. Particularly by law, banks need to provide reason codes, which is actual reasons why that customer was rejected. And the customer might also ask, what should I do so that if I apply next time, I get it approved? And these are called counterfactual explanation. I'll give you an example shortly. The second type of explanation are explanation as diagnostics, particularly important for developers of AI models. For example, AI used, I don't know, in algo trading, right? So the people working on these algos, they want to understand how does this algorithm work internally, and particularly what are the main drivers in terms of features of my models. And again, temporal reasoning plays a key role here. Finally, explanation as verification and testing. And that's particularly important from risk management. The key question you can think of is, how does the model behave in stress test scenarios? So you want to analyze whether the model is robust enough to big changes, for example, either in the world or in the data used for training the model. More broadly, when we talk about explanation, we distinguish between global explanations, which try to explain the overall behavior of model, versus local explanations, whereby the goal is to explain the individual decision, prediction, or output, more in general, of a model. Okay, there are, I would say, two main approaches to XAI. The first one, and the most used, is feature importance. The goal is how to identify the features that are the main drivers of the model. So they are more important than others in making the decisions. Why it's important? So it's important to understand the importance of features for generating reason codes. For example, the feature important can say the income was the main driver for rejecting the loan. So the reason code will be linked to the income. User trust allows to quickly understand, what they refer to, and also help give, identify hot behavior to facilitate oversight. I want to highlight, again, as a someone highly involved in XAI, that feature important is clearly an important contribution that has been made to XAI. Is not enough, I think, okay? Because it's not enough to use feature importance to describe the complex behavior of AI models. This is what feature important look like. So for each feature, you have a score. I can skip that. There are two main methods used for feature importance. One is LIME and one is SHAP. The main idea behind LIME is to approximate the model with the linear model on the neighbor of the query, so that then you can identify the importance of the feature in the given the input. And then SHAP, where the idea is to frame the behavior of features as a game, where what you want to do is to attribute rewards between the players, and in this way you assign importance to features. Again, I think they are a really great contribution to the research community as well as the industry, and they are widely used. Clearly, the more we go, the more identify more needs for XAI. I'll focus on SHAP just to give you a sense of how the same technique can be used in different ways and give different results sometimes. So assume you have this scenario here where you have a decision boundary where, for example, application for load get accepted or rejected, and you have the data manifold, and then you have the input X you want to provide an explanation for. Now, there are three ways you can use the feature importance given by SHAP, for example. The first one is the baseline SHAP, where the idea is that you take a reference point, say I was rejected, I take the best customer in the firm or the average customer in the firm, and I say, what's the difference between me and that customer? That's one approach. And SHAP will tell you what are the features whereby you are most different from the reference point. Another one is that instead of one single reference point, you take a training set, and then you try to identify the difference across the average in this training set. The last one, which is what we focus on, is counterfactual SHAP, which is I was rejected, so I take a set of customer very similar to me who were accepted, and I try to understand where I differ so that I can try to do something to get accepted next time. Feature importance over time, I want to give you a concrete sense of how temporalism in XAI can help doing things better. So what you see here, I omitted the details, but you can still get the main message, I guess. So top graph is the value of one market feature. And as you can see, there is a change in the value, an important change. This is when last year COVID hit first. So it's not surprising, okay? We were expecting such a change, but the benefit here is that you can identify, measure this change. The second thing is the output in terms of the contribution of the same variable. What is interesting here is that, again, this is a model we try to play with. What you see here is that compared to the big change in the value, there is not a same change in the output, okay? So the contribution seems to be the same. So this might suggest, we need to identify and to debug and to diagnose the behavior. That's an example of how XAI can help in particularly analyzing the model behavior. Counterfactual explanations. Again, the idea is that with counterfactual, what you want to do is to say, how should the input be different so that output is flipped, for example, from accept to reject? This is an example I want to skip given that I'm conscious of time. X is the input. You have two ways of moving and changing the output, so A or B. Let me skip that. I want to move into this slide, which I think is very important. So what are the main challenges with XAI? First of all, actionability versus key drivers. Reason codes must be actionable. For example, if I reject a loan, I cannot say the main driver is your age. I cannot tell you should be 10 years younger, because that's not actionable at all, okay? At the same time, I want to understand what the main drivers are. So there is this trade-off between actionability and key drivers, but also measuring actionability is challenging. It's not always clear what is more actionable or more easily actionable for a customer to become a good customer for the bank. The idea then is to learn the actions from the past, what the customer actually did to change their status. The second point, which is really, what really focus of my research, because it's really there to me, is robustness of explanations. So assuming I tell a customer, you were rejected because your income was not enough, you should earn X more. I'm just putting by example. Now, if I tell the customer you should earn X more, I want to make sure that if the customers try to improve and come back in a month with a salary X more, they don't get rejected because now they needed X plus Y, okay? So in a sense, that's true in general. The better you explain your models, the more you are committing to some extent to the future behavior of the model. So how to formalize the robustness of explanation as a function of current explanation and the bound in the changes of the model is a very, I think, fascinating problem for me, a formal problem that needs to be addressed because it's crucially important, particularly in finance. Effectiveness of explanations, I mean, we need to make sure that the users are really finding the explanation helpful and useful. So user studies are very important to assess the explanations. And finally, counterfactual for regression models. Again, the state of the art is quite good in classification, so counterfactual for classification, how to flip the outcome. When it comes to regression model, it's much more complicated because the state space for counterfactual in regression models is huge. I just want to mention we have a paper on counterfactual for arbitrary regression models. I don't have time to go into the details, but I want to give you the flavor. In binary classification, as I mentioned, you want to find a minimal perturbation of the input so that you flip you switch its classes from 0 to 1, from accept to reject. In scalar regression, instead, you want to find a minimal perturbation of the input so that the output is sufficiently different from the output in the first case. What we did was to use an approach where we use a surrogate Gaussian process, we train it, we then optimize the acquisition process, the function, over that process, and we keep training and sampling until we converge. The good point about this is that it's very efficient and most importantly, can handle any arbitrary regression model. So we are not constrained to a specific model. The code is open source, so can be is available and can be used. Reach out if you're interested. That's just one example of what counterfactual looks like in the regression models setting. What you see here is 4 different counterfactuals, and let's focus on the last one. The idea is that this is telling you how feature 1 should change positively and how feature 2 should change and feature 3 should change negatively in order to get a different output, which is a percentage of the initial output. So the percentage, let's say I want where the output is a number, I want that number to be 4% or 4% more or less than the initial outcome. And this gives you the changes in the feature so that actually you get that different output. Again, the details are on the paper highlighted here. And closing, again, thanks to people helping here, I want to advertise a couple of things. Last year, in October, we co-organized the first international conference on AI in finance that was sponsored by ACM. It was a very big success because there was no conference specifically dedicated to AI in finance. There were a number of workshops in major conference, but not a proper conference, which now exists. ICAF is the name. Was a big success. And we also had a workshop on AI in Africa and women in AI in finance. I have one slide to highlight that really AI in Africa was a very successful event as a part of a program we have in JP Morgan helping Africa in terms of AI, how to foster AI in terms of education and the development of AI in Africa. And the reason why I'm advertising this conference is because the next one is happening now in November. Again, unfortunately, will be virtual, but you can look at the website for info. There are also a number of workshops. But for the future editions, workshops in formal methods for finance or temporaries of finance will be very welcome. So if you're interested, please reach out. We are super happy to collaborate. And one workshop will be the first international workshop dedicated to XAI in finance, co-organized by Anupan Duttal, Iman Lakaraju, myself, and Francesca Toni. And again, submissions are open, so feel free to contribute. The last thing is that, as I mentioned at the very beginning, we are very much engaged with academia. We also have a program of grants for faculties called the JPMC Faculty Research Awards, where we found grants across the 8 aspirational goals I mentioned before. And then this is a very important, for us, it's a great opportunity to do research with faculties. And has been very fruitful so far. So the next call will be mid next year. Again, reach out if you have interest, as well as for students, we have internships opportunity, PhD fellowship, as well as full-time positions. So we are hiring in London and New York. And as I mentioned, we cover a variety of interests. So feel free to reach out if you are interested. And with that, I close. And again, I thank you very much for listening, for inviting me, and for the attention today. Thanks.
Thank you very much, Daniele. So I think we have time for 1 or 2 short questions. I think there are 2 questions in the Q&A, so maybe you can just press the button there, read the questions, and then answer them if possible. Is that fine?
Absolutely. Okay, yeah, I can see them. First question from Rongku. So as an expert on formal method who is working in the AI field, in which aspects do you think formal methods can be combined with AI in the financial markets or generally all application fields? So that's a great question, which is very dear to me. The first answer I will give is that to make AI safer and more trustworthy. Because at the end of the day, when it comes to using AI for practical applications, risk applications, people are still scared, and trust around AI is a critical topic. There, I think formal methods can really help. For example, one project we now have, which I forgot to mention, actually I should have done, is on verification of neural networks or learned models. To be able to assess the robustness and safety of AI is a critical, really critical application. The second question is from Mohammed, so Usama Sardar. So thanks for talking. Can you tell the other use cases in finance where AI data is required to be confidential and private? Sure. So first of all, well, I mentioned about fraud detection. There are clearly confidential issues there, but also about, for example, payments, right? We handle trading and we handle payments, investments. There is a lot we can learn from the data, but as you can imagine, they need to be confidential. So we work a lot on privacy preserving AI, which is a crucial requirement. So in all things involving payments is important. Also, when it comes to customer journeys, for example, you would like to provide better recommendations for customers. Ideally, one recommendation for every customer. Okay. However, you need to keep the data and the privacy of the customers safe. So in those scenarios, we need to be able to reason with this data, but in a preserving privacy fashion. So that's really a nice topic. Thanks.
Any other questions? So otherwise, I have one short question, in fact, related to the first one, but the other way around, about knowledge transfer, because I believe that in the formal method community, you have a rich set of techniques that are applicable or adaptable to other areas. I mean, I'm sure in your previous work, if you look at robotics, then you have multi-goal problems where you want to combine a planning collision-free and dynamically feasible motions, also with reason temporally about the motion of a robot. So now, such knowledge that you have built in your previous research, how useful is this in this new application area in the financial world? I mean, is it a way that you can abstract things so you can attack problems in?
That's a fantastic question, Paulus. Thank you very much. And yes, it's part of our work to talk to the business, understand what the problems are, and figure out how to use what we know. For example, I work a lot on task planning, path planning, and if you look at the payments, after all, it's a network of money moving across waypoints, if you abstract, okay? So there is a lot that can be done there, leveraging everything we did in path planning, task planning, and dynamic constraints. Clearly, there is it's not an easy step to make. It's not a one-day job. It takes a while, but you are absolutely right. And it's part of our job to identify how we can leverage everything we know and we see in the academia. That's why we keep studying what's happening in academia and apply to the business domains.
And this is what I think your work is very interesting, because, I mean, trying to understand the other side is not easy. I mean, it takes time, as you say. But once you have done that, I think you can get a lot of things not for free, but I mean, you have a lot of knowledge that you can apply.
100%. Yes, I agree.
Yes. There are two more questions, I think.
Might be, oh yeah, I can see it. Maybe a quick question. Is there any current work or interest in JP Morgan for confidential computing for use case? Well, yes, definitely. Please reach out. There is a lot of interest. As I mentioned, privacy preserving work, confidential computing is really important. Also, I didn't mention we work a lot on security protocols, okay? How to prove the security of protocols that are used in finance. If there is anyone interested in that space, please do reach out. Any application on quantitative model checking in finance? So actually, I did work on model checking, which is part of what I'm trying to bring in the firm. It's quite new model checking in finance, but it's definitely there are huge opportunities, including quantitative model checking in finance. Again, this could be a project, right, for one of the faculty research award I mentioned, how to exploring techniques that are currently not used with potential application in finance. So you are all very welcome. Please reach out. I will be delighted to talk more.
Okay, I think that's it for questions. So thank you very much, Daniele.
Thank you.
For an interesting presentation. Thank you.
Thank you for inviting me, and please feel free to reach out. Thanks a lot.
Bye.
Bye.
Thank you, both of you. We'll do a short break of 10 minutes, and then we will have the Best Paper Award presentation for Concur. So see you at 10 past 1. We will announce the winner of the Best Paper Award for Concur 2021 on behalf of the PC chair, Serdad, and myself. So, but before that, I think Nomadic Lab was kindly accepted to sponsor this award and in general the conference of Concur. So we would like first to give some time to Michel Moni, the leader of this company, to present it and to see why it is interesting for our community to interact with Nomadic Labs. Michel, it's to you.
Yes, thank you. So I have a video, but I can also give my presentation live. What do you prefer, Benoit? You've been testing the video. What do you think?
The videos, I think it will be better live.
Okay, let's do that. Let me share my screen. Yep, that one. Okay, can you see my window?
Yes.
Okay, let me put it full screen. Fine. Okay, can you see it? Oops.
Yes.
I'm sorry, I'm losing my, I have too many windows. Okay, so I'm happy to be with you. I am Michel Moni, the CEO of Nomadic Labs. I have been a researcher myself. I've been working at INRIA during a few decades in the field of programming languages, in particular on the OCaml programming language. I was at INRIA Concur, then INRIA Paris. But since a few years now, I'm working with the Tezos project. And more precisely, inside this company named Nomadic Labs, we are based in Paris. Our mission is doing research and development. We have 60 employees, a lot of which hold a PhD in various domains of computer science. We don't do research, or we don't do much research internally. Our main mission is to contribute to the development and the evolution of the Tezos blockchain, to prepare the future of the blockchain, and to help economic actors to design and build their own projects on Tezos. We have an adoption department for doing this. So what is Tezos? I guess you heard of Tezos, but in case you did not, let me remind you a few properties of that project. So Tezos is a blockchain. It's fully operational. It's up and running since a few years ago now, 2018. So compared to similar infrastructures, blockchains, Tezos is eco-friendly. It uses consensus algorithms based on proof of stake instead of proof of work like Bitcoin or Ethereum. That makes it more reasonable energy-wise. That's one particularity. The other particularity, and maybe the main property of Tezos, is that Tezos is evolutive. It's up and running, and while it is running, the code can be modified. This is called an amendment, and that these code evolutions allow the blockchain to evolve, to integrate new techniques, new algorithms to fix or set some parameters of the chain. So the claim about Tezos is to the blockchain Tezos enables the adoption of tomorrow's innovation without disrupting the network. So far, we have been integrated successfully 7 amendments. The 8th one is under preparation. It should be integrated in a few days from now. The idea is that code is voted by the community, by the Tezos participants, and if the vote is successful, then the new code is activated at some point, and the blockchain starts in a new setting with that new code. And the last, the third element about Tezos is that it's supposed to be reliable. We try to use advanced tools coming from research teams. We try to choose the safest programming languages. Most of the code has been designed with formal verification in mind. In particular, the smart contract language, Michelson, is a kind of typed functional programming language that can, not easily, but that can be formally verified, whose properties can be formally verified. So in that respect, we are very close to research, because we try to use recent techniques. The architecture of the blockchain, of a node of the chain, is, we can see that as an octopus. There is a blue part that is called the shell. You can see here under my pointer. that part is in charge mainly of communication. It's this is where the peer-to-peer network is implemented, the distributed database, local storage, the validation of blocks and operations, and that that shell part can be requested through remote procedure calls here in the yellow through the yellow arrows. That allows to access the state of the blockchain. The green part of the octopus is called the economic protocol, and this is precisely the part that is submitted to evolution, that can evolve, the amendable part. This is where the consensus algorithm lies. So Tezos can change its consensus algorithm, but also the smart contract language and a few other things. That part runs exactly the same way on all nodes, and its interface to the rest of the code is as narrow as possible, of course, for the evolution to take part gracefully. The research and development activities that we have in the Tezos project, not only in Nomadic Labs, spans over multiple areas, because blockchain integrates a lot of technologies, distributed systems, cryptography, code security, programming language design and semantics, formal verification, but also governance, economy. The blockchain is, the role of the blockchain is to provide, to be an infrastructure on which values gets exchanged. So there are economical incentives and mechanisms that are set up on the blockchain, and of course this is something that is that can be studied, that needs to be studied, and that does benefit from research. The research, I mean, the different areas on which there is research running and funded by the Tezos Foundation, I'll come to that later on, spans over different areas. So we try to improve our development tools. This is the basic tool that we are using, programming languages, but also testing and monitoring frameworks, static analysis, Prof Assistant. The goal is to strengthen, to increase the efficiency, the reliability, the correctness, and the security of the chain. Another big area is about scaling for the blockchain, for Tezos to adapt to the use cases, to be able to scale to the usage. So this involved to certify the correctness of some crucial tech part of the chain, but also to invent or integrate consensus algorithms, more efficient consensus algorithm, to design the economic incentives of the chain, so that the nodes of the chain, the bakers, it corresponds to the miners in Bitcoin, so that they get the right incentives to contribute honestly to the blockchain. So everything about voting, any aspect of governance, this is of interest for us. Of course, privacy, cryptography, in particular zero-knowledge proofs, that's something that is really interesting for us. And the goal is to scale Tezos to the use case and to facilitate its usage. We do some development internally, of course, and some research. So we contribute to the core development of the blockchain. We contribute to release one version of the shell in particular, but also to the design and implementation of amendments. And this is in general in collaboration with other development teams around the world. we do internally formal verification, in particular when it comes to strategic smart contracts. We are developing internally a framework for formally verifying Michelson smart contract. It's called MICHOCOC. And we have partnership with INRIA and IMDEA Software Institute in Madrid, with whom we collaborate on several kind of fundamental research actions, either on trying to invent or develop new technologies for design consensus algorithm, for instance. This is one of the actions that we have with IMDA, or to contribute to the improvement of the basic tools that we use, like COC, F-star, or the OCaml programming language within AI. The research developments or projects that are funded by the Tezos Foundation, many of them are available, are being presented in our research seminar series that you can find on our YouTube channel, Nomadic Lab channel on YouTube. And if you, yes, so there are quite a few presentations that are already available on that channel. So this is about our internal research. The Tezos ecosystem, so the Tezos Foundation, who funds, support the development of the project, also grants research institutions and companies to do research, to develop better tooling, and of course funds the different components of the ecosystem to contribute to the core and to the amendments of the blockchain. So there are a few teams that work full-time on contributing to developing Tezos and the amendments. If you're interested into contributing to research or tool development for the Tezos project, you can go to the Tezos Foundation, the grant platform of the Tezos Foundation, grants.tezos.foundation. There is a kind of form that you can fill on which you can describe your research project or your project in general, not necessarily research. The scope is pretty broad, research, tooling, but also community animation, applications. And that's a way for requesting some financial support from the foundation. Your request will be reviewed, evaluated, and you will get a reply normally pretty soon. These days, it takes a few weeks to get a reply for applicants. We have a global website, tezos.com, on which you can find documentation, jobs description, and everything. And of course, if you want to contact us at Nomadic Labs, we are in Paris, close to Université de Paris, Rue de Tolbiac to be precise. Our website is at nomadiclabs.com, and you have a few links here, our GitLab repository, and Labonomad on Twitter. I guess that's all I had. As you can see, I have no particular message to the Concur community, but since a blockchain and Tezos in particular is about distributed systems, of course, we are very interested in concurrency and any aspects that are of interest of the Concur conference. Thank you.
Thank you very much, Michel. So I remind you that Nomadic Labs is the sponsor of the Best Paper Award of Concur in general for Concur, and we thank them very much for that. And I hope you realize why it's relevant for the Concur community to interact with a company like them. So now for the moment everyone has been waiting for, at least some people were curious to know who is the winner of the paper. So just rapidly, because we want to have lunch, everybody, and everybody wants to know the winner. So the procedure, we had 35 papers accepted at Concur this year out of 96 submissions. So the percentage is about 37%. We will discuss this at the business meeting on Friday. So the procedure we followed was the one. The PC member had to vote for 2 papers they considered to be good papers. And then the PC chairs, that is myself and Serge Haddad, had to read the papers, the 4 most nominated papers, and choose the best one. So that was the procedure we chose to follow, but then it was not necessary, because after the vote of the PC member, 1 paper stood up, so we didn't have to change the decision of the PC members. So 1 paper had more votes than the other ones, and it's clearly the winner. But still, we decided to nominate 4 papers because they were nominated by the PC members and they deserve to be mentioned as nominated papers. And so we invite the attendees to read them and to follow the presentation. So the 4 nominated papers are the following. A paper by Richard Meyer and Eric Monday, Strategic Complexity of Mean Payoff, Total Payoff, and Point Payoff in Countable MDPs. So this paper will be presented tomorrow in the session at 14-hour Paris time. The second paper nominated, the order in the nomination is the order in which the paper was submitted to EasyChair, just to be fair. Léonard Brice, Jean-François Raskin, and Marie van de Montgard, Subgame Perfect Equilibria in Mean Payoff Games. So this paper is presented today, later today, at the session starting at 17 Paris time. The 4 nominated paper by Storten Wiesmann, Stefan Milius, and Lutz Schröder, explaining behavioral inequivalence generically in quasi-linear time. This paper is presented on Friday at the session at 14-hour. And the last nominated paper is by Simon Fowler, Wen Kokke, Ornella Darda, Sam Lindley, and Garrett Morris, Separating Sessions Smoothly. This also is presented on Friday. So for all this paper, I recall you, there are teasers on the YouTube channel. I invite you, okay, 1 paper has not sent the teaser yet, but the other ones have nice teasers, so you can find out what they talk about. And so just check them when you have a little bit of time before coming to the presentation. But now, the moment everybody is waiting for. So who is the winner? The winner is, by the way, also the paper not only that was nominated by most of the PC members, but also who had the best score in EasyChair. Had 2 accept and 1 strong accept. So it's clearly standing out. And is the paper by Léonard Brice, Jean-François Raskin, and Marie van de Montgard, Subgame Perfect Equilibria in Mean Payoff Games. So we take it's, I gathered the first author is not yet a PhD student, is still a master student in Brussels. So it is quite a feat that this paper was nominated and liked by so many people. So these people will receive a prize of 500 euros. Thanks again to Nomadic Labs. We will contact the authors to figure out how to pay them, because technically it's not so simple, but we will figure out a way of doing it. And congratulations to them again. And I guess we don't need to make it longer. So I pass the, Benoit has a few announcements to make. And I just wanted to say that the first session will start soon in half an hour. So there are 4 parallel tracks. You can either go to the Zoom session using from the link in the program on the website, or you can go to the gather tone and walk on the virtual venue to the room of the corresponding track. And then you will have the first sessions. So if you don't have eaten yet, bon appétit, and see you soon.
Thank you.
Thank you, Michel.